Good morning, everyone. It's great to have you all here this morning. Thank you for joining us in our webinar. So we are PLM Central. We design innovation. We are a technology firm, and we are a reseller that support and work with all kinds of PTC products. And today, in today's webinar, we're going to be talking about the release of CREO 9. So this is the newest and the greatest, and it comes jam-packed with a lot of features. So obviously there's a lot to go through in this webinar. My name is Colin. I am the applications here at PLM Central. So on today's agenda, we're going to be looking at CREO 9 and the core modeling. We'll look at some of the selection enhancements. We'll look at the user interface and user experience with the design tree enhancements. And that will also include some of the user interface changes or enhancements in the sketcher. We'll look at some things that they've improved when it comes to offsets and projections, etc. So let's go into the core modeling. So we'll talk a little bit about the sketcher, the divide surface, patterns, and holes. So the sketcher overview, they have modernized the offset and project tools. So if you're used to, the standard CREO 6, 5, 7, they all have the same user interface, but they've drastically improved this in CREO 9. So obviously they've enhanced the tool workflows. So you have these, as usual, the standard chain collection. So they've also enhanced the reference handling, aligned between 3D and 2D. So this just helps with easier referencing when using 3D geometry, and improved usability for easier creation and faster dimensioning of your sketch. So another thing they've added also is the auto scale first sketch. And what that means is once you change dimensions, if you have late state changes, it auto scales all the other dimensions. So you don't skew the workflow or your shape too much. So as some of you might be already familiar with when you're designing, and if you have a complex shape, and you change a dimension here and there, that can quickly skew the shape, and it can make it difficult at times to scale that up. But with this auto scale feature, CREO 9 makes it very easy to do that. So enhanced enriched inspection tools. So they've introduced this in CREO 9. You can highlight intersections and junctions, and also diagnostics remain active. So this can help and fix your sketch geometry problems faster. And obviously this just improves or increases your design productivity. So like I mentioned, they've modernized the project and offset tools and modernized the user interface for using this. So like mentioned before, you have the standard chain and obviously the loop selection workflows. So I have an example that I want to show here very quickly.
Offset tools in the Sketcher environment are modernized in CREO Parametric 9.0. Both present themselves with a modernized tool UI, modernized workflows, and modernized reference handling. When invoking the project tool, you see the new tool user interface with the chain collector activated, allowing you to select edges in the 3D model and project them into the sketch. In CREO 9, you now have the same chain selection methods available as for 3D operations in the part modeling environment. Hold the Control key to pick individual edges to create a 1x1 selection. You can also hold the Shift key and press the right mouse button to toggle through available chain selection options, such as tangent selection, partial surface loop from two selections in both directions, and the closed surface loop option. The chain selection is confirmed when you press the left mouse button. The middle mouse button completes the tool. Using these mouse and keyboard interactions, you can now define chain references using the same keyboard shortcuts and workflows as in 3D. The following example shows a similar workflow referencing 4 circular loops as input to the offset tool. Press the Apply Repeat button to apply the current selection, leave the UI open, and continue with another reference chain selection. Users that prefer the detailed chain collection UI can also invoke that and define the chain rules, options, and references there. The resulting entity is a composite 2D curve that can easily be selected entirely. For example, for a delete operation as illustrated here. The modernized references handling is shown in the references dialog. It lists each collected chain as a single entry. When you select an entry, the composite curve representing the chain is highlighted in the graphics area. Replacing such a chain reference invokes the chain selection user interface again, so that the replacement chain can be selected very quickly. The modernized reference handling and definition of the chain references is also visible in the related sketch-based feature, for example, during an edit references workflow. As shown in the video, you can simply replace a single chain seed reference edge with a new one to regenerate the feature based on a new surface loop based chain. CREO 9 increases usability through modernized aligned chain selection workflows for the project and offset tools in Sketcher and makes referencing and usage of 3D geometry inside Sketcher easier.
Okay. So, as mentioned earlier, there are improvements in the Sketcher environment. And what I wanted to show here was the config options that allow us to see and fix geometry problems when we encounter them. So again, this helps to improve our productivity. So some mentioned here is the Sketcher highlight overlapping, the Sketcher highlight intersecting, and the Sketcher highlight junctions. So you can add these in your config options, and usually they might be there by default, but these again allow us to see our errors in our sketches early on. The next feature I wanted to talk about, what they added in CREO 9, was the divide surfaces. So this is a new feature, and it replaces the surface region. So as some of you might be already aware, surface regions were used in CREO Simulate, and these can now be used, these are now replaced with our divide surface. So the divide surface, again, we can create sketch projections that support solids and quilts. There's also the option there, once we divide a surface, we can always use the unify surfaces to join them back together. So this has a broad case of applications. It's mentioned again in simulation and generative design for core modeling and late changes, and rendering aesthetics. So we have an example here that we'll show that gives an intro to this new feature.
CREO Parametric 9.0 introduces the new divide surface feature. You can now use the capabilities of the new divide surface feature in core modeling and throughout the broader CREO environment to split a surface area into a new adjacent touching surface that is based on the same surface definition as the original surface. This helps to better support a broad variety of use cases, for example in the areas of model-based definition, visualization, simulation, part modeling, data exchange, and more. Divide surface supports two creation methods, sketch-based and chain-based. The sketch-based creation method projects the selected sketch onto a single or multiple surfaces and splits each of them into two. A flip option gives you control to define which portion keeps the original surface ID and which one becomes the new surface. Also, sketch region selection is supported for object action workflows with this creation method. An intent surface reference is created automatically for the divided surface feature. That makes it easy to select all surfaces created during the divide operation. Even if many surfaces are included in the operation, it is therefore easy to, for example, assign a color to all of them. A divide surface feature can also be based on chain references that lie within the selected surfaces. You can select multiple chains individually or use the advanced chain selection option, all curves in feature. The shown example illustrates this using intersection curves created between the main design body and the fixture body. The resulting new surfaces can then be used to indicate the contact areas between the bodies. The surface references can also be used in MBD-related workflows as fully semantic references for annotations, such as the shown leader node. Divided surfaces can also streamline some geometry modification workflows, such as the creation of an embossed or engraved label on a body surface. This can now be accomplished with three simple steps. First, wrap the label text defined in a sketch onto the surface. Second, use the wrapped curves to divide the surface. And third, use flexible modeling offset to offset the new surface towards the outside or inside of the solid body. Flexible modeling automatically creates side surfaces in that situation, which completes the workflow. CREO Parametric 9.0 increases design productivity for many use cases requiring surface areas as referenceable objects in the model geometry.
Okay, so some of the other use cases, like mentioned before, aesthetics, and we have an example here to show. So we can apply a surface finish, we can apply in appearances and textures, etc. And this is purely using the divide surfaces feature introduced in CREO 9. So let's have a look at that.
In this use case example, the divide surface feature is used to design the colored scale on the meter display as illustrated in the inlay image. CREO Parametric 9.0 introduces the new divide surface feature, allowing you to divide a surface into two portions in order to work with the surface area as separate surface. Dividing the two half-cone surfaces here with the selected sketch regions results in the upper surface consisting of three surface regions, sometimes also called contours, and the lower surface consisting of a single region. In addition to the divide surface feature, the new unify surfaces feature is available in CREO 9. You can use it to merge several previously divided surfaces back into a single surface. In this example, we unify the surfaces representing the small white dividing areas. The larger half-cone surfaces representing the display are then further divided based on curves outlining the numbers. As the divide is done for each of the two selected surfaces, this results in two surfaces for the numbers that are again unified with the unify surface feature. continuing to color the surfaces, it becomes necessary to separate the two surface region contours of the lower conical surface, as we want to apply yellow and red colors to them individually. Use the Separate Surface Region feature and its control options to separate out the selected regions. Note that the Separate Surface Region feature was previously called Split Surface and is renamed in CREO 9 to better differentiate and express its function. The Unify Surface feature also allows to reunify adjacent touching surfaces that had previously been created by the Divide Surface feature. The selected surfaces to unify are merged into a target surface, which will therefore be the surface that maintains its ID and properties, such as the assigned color. If required, you can optionally also update children feature references and forward them to the target surface using the Update Surface References option.
Okay, so some pattern enhancements which have greatly improved in CREO 9. So they've improved the regeneration of geometry patterns for identical attachments in certain situations. So this increases our flexibility. We can switch between simple and standard whole dimension patterns. So that's now supported, and there's no need for us to recreate any sort of patterns. So the regen time has greatly improved, especially if you have massive parts with many holes or patterns in one single part. The regen time has greatly improved in this. So obviously this increases our productivity for models, again, containing large geometric patterns. So let's have a look at this in action.
CREO Parametric 9.0 includes performance enhancements for the geometry pattern feature. This video illustrates the resulting increase in model regeneration speed by showing a CREO 8 and CREO 9 example side by side. The example will involve a fill pattern of a chamfered boss with a through hole. In the case shown, we select a group of features from the model tree as a basis for the pattern. When we create a geometry pattern in CREO 8, we see that the available regeneration options include the default option General as well as the variable regeneration option, while the identical option is grayed out. For the comparison, we therefore use the variable regeneration option in CREO 8. When defining the geometry pattern feature in CREO Parametric 9.0, you can now use the regeneration option identical in addition to the other previously available options. This enables faster regeneration of geometry pattern for situations where the attachment situation is identical for each pattern member. A typical example in which you can benefit from this increased performance is a situation where all pattern members attach to the same planar surfaces, as illustrated here. Other prominent examples include patterns in sheet metal design models. Overall, this leads to increased productivity due to a dramatically faster regeneration of geometry patterns when compared to the general option, and still significantly faster regeneration when compared to the variable option.
Okay, so let's look at some of these selection enhancements with smarter selection context evaluation for multi-body models and for visibility controls. So again, they've optimized the feature context evaluation. So when selecting geometry in the graphics, it shows what part or what feature has been selected in the model tree. So this skips body operation features to provide immediate access to the original feature. So you have quick access to your original feature context and optimize auto-locate in model and design tree. So they've changed the select from parent, which has now changed to select related. So the additional capabilities are to quickly investigate parent and children. So parent and children features of a selected feature. So we have a structured view showing the current selected feature and the path either from the top of the assembly, sub-assemblies, bodies, quilts, etc. So with this in CREO 9, we now have that tab to quickly show so we can investigate our design relationships. There's a new filtering option to include and exclude system references. There's a standardized and more flexible user interface, so you can actually pin the UI wherever you'd like on your design, in your design environment. And you can dock other components as well. Let's have a look at this.
CREO Parametric 9.0 sees the evolution of the Select from Parents tool into Select Related. As in the past, this structured view shows the path from the top node, such as a top-level assembly, via sub-assemblies, parts, and bodies or quilts, down to the selected feature for a quick selection of parent nodes. When the part is activated or opened, the shown structure within the part level becomes more detailed and includes parent features, the current selected features, as well as children features. Labels indicate that separation. The selected current feature is marked in bold font. The Select Related Component user interface is also enhanced. When you use the Pinned UI option, it converts into a full standard tree UI component that can be docked to other UI components as any other regular tree. To make it disappear, just hide it and reopen it from the Model Trees toolbar, or collapse it and expand it within the docked state. When you keep the Select Related tree open, you can therefore use it as investigation tool companion that updates with every selection change made in the graphics or in other trees. Selections from inside the Select Related UI do not automatically trigger a change of the current feature, so that you can select and interact with the parent or child features, invoke their context menu, and trigger a command, for example. Use the Set Current command from the mini toolbar when you want to change the current seed feature within the tree. Previous and Next buttons allow you to step through recent changes to the current feature. By default, the Select Related tree includes direct parents and children features, excluding the system references that represent, for example, topological relationships. Use the filter option System References to include or exclude these indirectly related parents and children of the selected feature. In CREO 9, Select Related allows you to quickly investigate design relationships. Use its standardized, more flexible UI to keep the tool open as design workflow companion.
Okay, so let's look at the model and design tree enhancements. So we see configuration and performance, features in custom groups, and quilt body evaluation tree, etc. So in the model tree, the configuration and user experience. So they've changed the model tree. They've added a few more features. So the toolbar in the tree, we can now hide and show certain objects. We have clearer access to the model tree features and columns. They've also modernized this model tree feature so you can uncheck or check whichever panel you would like. So you can save the model tree layout as well. And you also have an option for custom groups as well. So you can name your custom groups, you can create and add certain objects to that, and you can give it a name. So there's the benefits of this is clearer and faster access to your model tree commands, and easier tree setting management across modes. Secondly, like I mentioned, we have the custom groups, so the support for features in custom groups. In addition, you can add bodies and quilts. There's broader support for separate design tree in your part modeling. This can include additional applications such as sheet metal or simulation. And you can also use simpler default names. So we do have one last example here to show.
CREO Parametric 9.0 sees the design tree being enhanced in a number of ways. The out-of-the-box configuration of the separate design tree is optimized and shows consumed bodies and quills as well as their contributing features by default. Also, the general support of this tree in part modeling has been broadened to additional contexts and applications such as welding, simulation, and others. Simpler default names for quills now align the default naming scheme between bodies and quills. New quills are therefore simply named using a running number index such as quilt 1, quilt 2, and so on. The example in the video illustrates this with the snapshot creation workflow for a consumed quilt. Custom groups in the design tree are enhanced to support features in addition to bodies and quills. This enables you to group important datums or construction elements. More information on this enhancement is available in a dedicated What's New introduction video. Additional naming flexibility is provided for custom groups. You can have several groups with the same name, or use a name that's already used for a different object type, such as a body or quilt name, for example. Feature reordering can now be initiated from the contributing features list, as illustrated by reordering the round 7 feature in a way so it gets regenerated before the round 1 feature. Additional intelligence has been added to the autolocate capability when you select geometry from the graphics. In situations where the corresponding feature created more than one quilt or body, the feature is highlighted underneath the body or quilt that the selected geometry actually belongs to. In this example, we first select geometry from the LED 1 and then from LED 2. The external Add Bodies feature is therefore identified as the involved contextual feature in both cases, but highlighted underneath the expected body respectively. We added queries by type to the quick search. This allows to quickly search or filter down to all quills or all bodies, for example. You can also combine criteria, for example, to search for all hidden bodies. For the quick search, search criteria are typically connected logically with a Boolean AND condition. In the example shown here, we search for bodies or quilts with the visibility state hidden. This is possible as the new type queries are connected with an OR condition in contrast to the typical AND condition between the quick search criteria. All these enhancements provide you with additional flexibility to work with the design tree and organize design items.
Okay, so using CREO 9, you'd notice that there have been some changes to the options and your configuration editor. So when you go into your options, we can see our options available have been sectioned into their separate counterparts. So this allows for more flexibility. It's just a modernized user interface overall. It allows us to easily locate certain options that we may be looking for and other licensing options as well. So that concludes our webinar today. Thank you all for listening. I hope you did enjoy this webinar. I think we do have maybe 1 or 2 questions in the chat, which I'll have a look at now. And one of them is regarding configuring the zoom when selected. So yes, it is possible to configure the level of magnification when using the zoom to selected. And the config option available for this is your zoom to selected, and you can either set that to your yes or no. It's also a question concerning Elements Direct. So yes, there's still support for Elements Direct, and it's been improved. So there are some enhancements there as well. So there is improved data upwards compatibility and easier to reuse CREO elements, parts, or objects in CREO parametric. Okay. So thank you all for listening again. If you do have any questions or if you want more information regarding some of the features we looked at, feel free to contact us on the telephone number below or email info@plmcentral.co.uk. Thank you all for listening. I hope you enjoyed the webinar and enjoy the rest of your day.